Hello everyone, welcome to Shiwam's classes. In today's lecture, we are going to discuss exercise 3.2, which is part of trigonometry. So in this chapter, we are going to discuss problem 1, 2 and 3 and in further lectures, we'll try to conclude this exercise. So before proceeding to the exercise, let's first understand the concept behind this exercise. So this exercise talks about some values of cos theta, sin theta and cot theta, and they've been given in terms of some numbers, and also it's been given that in which quadrant they lie. So first of all, let's understand what is the concept behind this. So if you remember, we had this kind of quadrant system, and all the trigonometric entities in this quadrant, which is first quadrant, is positive, all positive. All right, in this only sine and of course opposite of cosine, which is cosec, would be positive, and then in this tan and cot would be positive, and then finally in this one cos and sec would be positive. All right, so this is the concept, right? And now if the values are given in some quadrant, then we got to figure out what entities would be positive and what entities would be negative. All right, so there is an acronym for it, or rather kind of a sentence. Generally people make use of it. The sentence is called add sugar to coffee. All right, so in this one you can see all, and then S stands for sine, T stands for tan, and C stands for cos. So add sugar to coffee is something people remember this rule with. All right, so now once we have talked about rule, let's try to discuss problem number 1. So problem number 1 says cos x is minus 1 by 2 and cos theta is in third quadrant. So I mean, just for our understanding, let's draw the coordinate system as well and then see. So okay, so now cos is here, and cos would be negative, of course, in third quadrant. So what is negative over here? If you trying to draw a line like this and theta like this, so what it tends, essentially cos theta is telling you is that this divided by your hypotenuse, right? So your cos theta here is nothing but, if it is your b and this is your h, so it's b by h, right? And you can see that if it is x-axis, it's y-axis, you can know that x would be negative this side, and that is why b is negative. Alright, so this is how we interpret it, but let's proceed further. You know cos theta, then of course you also know sec theta. So sec theta will be what? Sec theta would be opposite to it, 1 by cos of x, which is nothing but 1 upon minus 1 by 2, which is nothing but minus 2, right? Now when you know cos theta, you can also know sin theta, because you know this trigonometric identity, which is sin square theta plus cos square theta equals to 1, right? And since you have sin square, you don't have sin square x, but you have cos square x, which is 1 by 2 whole square, and which is here 1, and so it implies that sin square x is nothing but 1 minus 1 by 4, which is nothing but 3 by 4. And with this, what you get is sin theta as sin x as square root of 3 by 4, which is nothing but square root of 3 by 2, and it will be plus and minus, right? In third quadrant, since my sign is also negative, and as you can see that since b is negative, and even this p will be negative as well, because it's in the third quadrant, and then here y would be negative as well. So we'll have to take negative values of sin theta. So sin x equals to minus root 3 by 2. This implies cosec theta or cosec x would be opposite to that, which is 1 upon sin x, which implies it is nothing but 2 upon root 3 and minus right? Now coming to the last bit, which is tan theta and cot theta. So tan x is nothing but sin x upon cos x, and we have sin x as minus root 3 by 2, cos x as minus 1 by 2. So this is nothing but root 3. 2 would cancel out and minus minus would cancel out. So and then cot x would be 1 upon tan x, which is nothing but 1 upon root 3. Alright, so we have got all the values. We have got cos x, we have got sec x, we have got sin x, and we have got cosec x, right? So now let's move on to the next problem. So our next problem is this one. Here it is saying sin x equals to 3 by 5 and x lies in second quadrant. Again, just trying to reiterate the point. So if you have this quadrant, so it's here, it's saying in second quadrant. In second quadrant we know sin theta is positive, right? So now sin x equals to 3 by 5. This implies cosec x equals to 1 upon sin x, which is nothing but 5 by 3, just opposite to that, right? Since we know sin square x plus cos square x equals to 1, this implies cos square x equals to 1 minus sin square x, which implies 1 minus 3 by 5 whole square, which is nothing but 1 minus 9 by 25, which is nothing but 25 minus 9 upon 25. Alright, so cos square x is nothing but 25 minus 9 is 16, so 16 upon 25. So cos x is nothing but square root of 16 upon 25, which is nothing but plus and minus of 4 upon 5. And now we know that in this quadrant cos would be negative. This implies cos x is minus 4 by 5. So this implies sec x is nothing but 1 upon cos x, which is nothing but 1 upon minus 4 by 5, which is nothing but minus 5 by 4. Now coming to the last one, which is tan x. Tan x is what? Sin x upon cos x, right?